So what I want to do is give a brief update on the BioImage Archive, and that's really an outcome of many years of preparation, launched initially by EURO-BOIMAGING, but also to which this consortium made important contributions. So Federica already updated you on where EURO-BOIMAGING stands at the moment. So in Europe now we have the wonderful infrastructure that unites many countries together to provide access in a coordinated way to many different imaging technologies. And so that was recognized by the European process that builds Europe-wide infrastructures, ESFRI, the European Strategy Forum for Research Infrastructures, as a landmark achievement last year, which made the whole EuRO-BOIMAGING team very happy. And we are now in the last phases of the European Commission translating the legal statutes of EuRO-BOIMAGING into a binding intergovernmental document that will make it its own institution and entity in the long term, still this year in 2019. So that's excellent. Now, from the very beginning, EuRO-BOIMAGING recognized that giving people access to the instrumentation is only one part of the essential services that need to be provided, but that all of the modern instruments of imaging technology produce a tsunami of data. And these data rates are already outdated every time I show them. They keep going up every month, every week, and every year. So we are dealing with a very large amount of data that for the typical life science laboratory is actually very difficult or impossible to manage. And I think all of us face this reality whenever we provide service. So from the beginning, EuRO-BOIMAGING had a very active discussion with the people who do data support for life sciences and said what is needed in the long term as a general public infrastructure to support this better. And so we came up with this concept in EuRO-BOIMAGING that we really need two pillars of public data support for the life sciences. On the one hand, we said we absolutely need a public archive where all the published and quality controlled and curated image data can be stored and made available to the community, so that data can be compared, that data can be reanalyzed, and that we can fuel the new nascent discipline of bioimage informatics with a lot of data, because that's very data hungry. Now, on the other hand, looking back at what happened in genomics starting in the late 80s, we said immediately when you share data and you make it available, you will also have to give tools to the community in order to do this analysis. Because again, many life science laboratories who produce the data are not necessarily specialists in doing in-depth data analysis. They would like to have convenient, publicly available tools in order to compute on the data. So the second pillar on this slide is really how do we also provide tools to look at the data and reanalyze it again. Now, looking at the volumes of data and the difficulty of moving them around, I think all leading facilities are still moving them around by shipping disk around the world. It was clear that these services need to be provided over the internet. It needs to be accessible to any life science lab without having to ship disk around. So we thought about this in EuRO-BOIMAGING very hard and said, we have now this wonderful new EuRO-BOIMAGING ERIC. It will be coordinated by 3 entities in Europe. We have the statutory seat and home to the intergovernmental legal entity in Finland, and Jan Ellenberg is here as a representative of the seat. We have the coordination of medical imaging in Italy, and we also represent the medical hub of EuRO-BOIMAGING here at this meeting, and we have coordination of the biological imaging at EMBL. But we need data, and we need public provision of large-scale data services. And so that, in the end, we decided would be hosted by EMBL because we are already doing this for genomics. And it is the largest public data provider in the life sciences in the world, largely in the genomics field. We have 2 very large data centers we operate, one in Kingston at the site in the UK, one in Heidelberg. And we're doing a lot of provision of large-scale data and cloud capacity for the user community on these data types. So it took actually quite some discussion within EMBL, again triggered by our role in EuRO-BOIMAGING, to say we should start to take this seriously. Image data is in the end going to be as important to life science as DNA-based data, but it's more difficult to deal with and more difficult to build the infrastructure. And had a series of discussions and a series of workshops, and I think one of really the culminating workshops was this one in 2017 that then triggered also a white paper publication a year later in Nature Methods, where we said we really have a need to create public archives for biological image data. This is needed by the community. We need to do something about this. And the key arguments are that it will provide the foundation for the reproducibility of research that relies on bioimage data. It will provide reference data sets to the community that would like to standardize their work for particular research objectives, but especially also to the computational community that need data where ground truth is known and therefore can develop new artificial intelligence-based tools to enable new scientific discovery. And this whole discipline that is just starting up, bioimage informatics, is extremely data hungry, and we need to support and nurture this because they are going to be the people that provide us with the tools for our future research. So this call was made, the case was made, I think it was convincing. Case both to EMBL's governance, but also to the funders of such an effort. And so we are very glad that only a year after the publication in Nature Methods, we actually could get the resources together to launch the BioImage Archive as a new public service by EMBL. It's a long-term sustainable effort. And this is very fresh and new for us next to the genome data services provision, but it is already in operation. And we are constantly working now with the community to define for the diverse types of image data what are the minimum metadata standards that are needed in order to make the archive functional and performant. And so the next workshop for this is on October 14 in Kingston, but it's not going to be the last. This is really a continuous discussion with the community, as it has also been to develop the databases and services in the area of genomics and proteomics. This is something, as technologies evolve, that you refine and redraft. But I think the emphasis here is on minimal metadata standards. It should be as easy as possible to put your data in the archive, but there has to be enough information there that it can be reused and that it is useful for the community. So from the EMBL point of view, we hope that the archive really will be very enabling. On the one hand, it should take all the data associated with the scientific literature that will sometimes be provided directly by imaging facility. It may be provided by the journals when they publish scientific papers. It will be provided by other data brokers that are databases the community is familiar with, such as BioStudies, for example, that already has indexing of any type of experimental studies from the life sciences, or Empire, which is the EM raw data archive that we launched about a year ago to help this field because they had a very urgent need to put the data somewhere. But we expect that more data brokers will come up that really fuel the archive with new data input. Now, one very important outlet of the archive are computers. So directly via the internet and via APIs, bring this to people who want to do computational analysis and work on the appropriate connections for this to work. But then also databases that serve particular areas of image data to a community in a really easy to use form, because the archive will have relatively minimal functionality because it covers such a broad area of image types. And so we are going to need, and we already have, pilot efforts again developed in EURO-BOIMAGING and Global BioImaging, like the image data resource that Jason will talk a lot more about, that especially with the levels of cells and tissue type images. We have Empire that also now is adding value to how people can browse this in the EM area, but we hope that we can work with the global community to say in which areas of image data do we need added valued resources that take that part of the images from the archive and serve it in a really easy to browse and easy to analyze way to the user community. So this is just the underpinning is to make the data available in the archive, which is scalable. It will not break down if many, many more data sets come in, but to have a very close relationship to the input side and the usage side of this ecosystem of data resources. So it was mentioned before that we have a European process to look at cloud computational resources for the whole area of scientific discipline. That's called the European Open Science Cloud, or EOS. And this really was a trigger for us to think about also the next step. Once we have created the archive, what do we do about the image analysis tools and how do we best provide them to the community? It was clear that the cloud would be the solution for that. And so we worked together with the other research infrastructures in Europe in the biomedical sciences domain, which are 13 different ones. to create a project called EoEIV, whose mission is to provide an open and collaborative space for digital biology in the cloud. So any life science data that you would like to analyze, create the tools and the data resources that are needed for that in the cloud. Like many EU projects, this project has many work packages. I won't go into the details, but EuRO-BOIMAGING is very much engaged in the first three of these projects is to look at the data resources that need to be linked up to the cloud, and especially to start now to develop an infrastructure so that the data analysis tools can be combined in the cloud and people can run workflows on existing data to reanalyze it. And I think that's really a key task for the future. So this project is driven by real science. So there are use cases that come from the community where people say, this is what I want to do. I want to analyze these 15 data sets with that question, and that's my computational workflow. Can you put this in the cloud for me and give me automatic programmatic access to that kind of functionality? And based on these demonstrator projects that we identify in open calls, we are then putting the infrastructure in place to be able to do that. It will have a pilot function. It will demonstrate how something can be done in principle, but it won't be scalable just from this project. It will just develop the underpinnings, how you do this. And then we are going to need a lot more investment into this. And this is from a slide that we recently discussed with the European Commission for the future funding programs to say, what are we going to need to move forward in this community? And so I think it's already become pretty clear from what we've done so far that the cloud compute infrastructure, the physical infrastructure you need for life science, is often in nature a little bit different than the one that has been built up for high energy and particle physics. The workflows change a lot faster in life science, and they are much more graphics heavy than in the physics community. So the type of architectures you need and also the IT support is different. And so we really need to configure this in a specific way for life science and invest in that. We need to provide open access to it, and coordinate it in high quality means that the users actually can do something with the data and really use it. It's not just dumping data somewhere on the internet with an URL and nobody can do anything with it, but actually provide very high quality data. And one key step in that is the curation, that you invest in the people who support the users to deposit the data in a way that it can be reanalyzed, that all the essential data that David just talked about is there, and that you can compare it, and you can aggregate data and draw conclusions from it. That's a lot of work, but it is essential to make it fair. So fair is the big buzzword in Europe about data. It means findable, accessible, interoperable, and reusable. That's what the Commission decided all scientific data has to be. But to actually make that a reality is a lot of work and takes a lot of money. And the Commission doesn't yet provide all of the resources that are required for the fair vision, so we need to work on that. Now we also need to still train people a lot in how to deal with bioimage data at all levels. Global BioImaging made already important contributions for that, for our service staff. It is about data management, processing, analysis. This is not easy to do. We need to educate more people how to do this. And finally, I think we really need to support the bioimage informatics community. This is a small community at the moment, and they are extremely data hungry. And we need to help this community to grow, to become more powerful, and to support us better with the future tools. So for me, these, for the future of our disciplines, are key areas to invest in that we need to work towards. So that's what I wanted to say. I want to end again with this picture of global bioimaging. I think these problems I outlined now from the European perspective and where we are in providing public services that are open to the world from EMBL are global. They are really universal. It's not anything specific about Europe, about these issues. We all need to deal with it, and we all need to find solutions to it. And that's why I think this consortium is so fantastic, that we can really make sure what we develop works for everyone, and that we also integrate the fantastic expertise and competence around the world into the tools and the development that we then make publicly available. So that's the update. And I want to just briefly say that we discussed yesterday at the management board that we are opening a new building for image data services at EMBL Heidelberg in 2021, and it will be really a pleasure for us if all of you come for after the Japan meeting to EMBL to have the Global BioImaging workshop in 2021. So thank you very much. If there are questions, one or two, I can take them now. Otherwise, I would hand over to Jason Wojtek. Let's see who's faster.
Yeah, thank you for that really terrific overview. I really enjoyed it. One of the things that I've sort of always found a little bit missing with large-scale cloud computing projects focused on the life sciences is actually, I guess, a really important early and perhaps quite boring step, which is fundamentally the data capture of the experiment, the actual capture of the experiment. In our experience, if you don't integrate with the instrument, if you don't work right at that interface between the actual microscope and the experiment going on and the microscopist, you don't end up capturing the data, and then you only get it back sometimes down the track. So it ends up on a laptop, it ends up on a lab server within a specific laboratory, and then it never actually makes its way to the cloud where this rich environment can actually help. And so I'm just wondering if that's sort of within scope, whether that's a consideration. It's usually an institutional concern ultimately, but I think it can get missed sometimes at a lot of institutions. Are you able to comment on that?
Absolutely. No, I think it's a very important point. I couldn't agree more. And indeed, with our EMBL core facilities that provide imaging services, we now enforce data management before people book the microscope, because otherwise you lose all of that. So I could not agree more with that. I think you probably noted yesterday when Naoto introduced the theme of the next EoE that we will have the pleasure to have in Okazaki in Japan, but that's exactly the subject there. How to deal with pre-publication data management, and I think the very first step of that at data production, you've got to make sure you capture all the information and you already at that moment educate your users that this is essential for them to actually have value in their data, and make them aware that they acquire data that may not just answer the specific question they have in their project, but that may be of value for whole community later. And so to enable that value, that's the key critical first step. And I think, although of course every institution has to install those processes, that they can have them, the service facilities have a key role, because they talk to the users, they educate the users, and just as they need to make them understand how to use the microscope, they also need to make them understand how to manage the data and how to capture the data. And I think we, as a global community, have a key role to play there to again say, this is what we recommend you to do, so that we provide guidelines for how to do this well. Yeah. The detailed technical solution will need to be a little bit adaptable from institution to institution, but the general principle has to be universal. Yeah. So absolutely, I couldn't agree more. And so that's the future, to really develop this well, and to also come to general agreed principles that then every institution who sets up a new facility can look at that and say, okay, this is how we need to do it. Yeah, absolutely. But it's a very important point. Okay, I think, again, in the interest of time, I think we should move on. And the next speaker will be Jason, who will talk about public data resources together with Shuiti.